Hi. I'm going to talk about the work the last few months on MapReduce. I've been working on MapReduce for about 5 years now. Doing full-time MapReduce at Yahoo. I think the dev team here, which means I get to be responsible for pretty much any line of code and things that we deploy. Can you hear me? Okay, perfect. I've been a full-time contributor to Hadoop since 2006, and I'm a PMC member. Okay, let's go. This is MapReduce today. Most of you have taken a look at this, used it. Is there anybody here who's not on the MapReduce job? Sorry, that was a good question. The MapReduce framework has two major components. It's got a job tracker and it's a bunch of task trackers. The job tracker, of course, manages resource scheduling and application lifecycle. Does job scheduling, figures out which task needs to run, where it needs to run, is it succeeding, is it failing, everything, right? And then you have the task trackers, which are just the workers. They get the task from the job tracker and just run. Okay, so things are great, right? But not. What are the issues we've had? Especially at Yahoo scale, where we run at this point multiple clusters of 4,000 nodes each, we're badly hitting the scalability limits, right? Owen mentioned about our favorite users, love taking the job tracker down, but we really can't push the nodes, and we haven't been able to push the framework at all, right? We've done 4,000 nodes, but again, we've got to remember that we've run 4,000 nodes of 2009 and 2010 vintage. As we go into the future, every node is going to be twice as capable as the current one. So we're badly hurting there. In terms of the cluster itself, one of the dimensions along which we measure the job tracker is how many concurrent tasks can it support. So if you have 4,000 nodes and it can support 10 or 12 or 20 tasks per node, that becomes a scalability bottleneck, right? So at this point we run 40,000 tasks on a 4,000 node cluster, sometimes a little bit more. But going further is hard. One of the big issues is that we've got very poor synchronization with the job tracker. Anybody who's ever worked on Hadoop MapReduce will tell you horror stories about it. It's a single point of failure, which means if the job tracker goes down, you lose all the jobs in the system. That's bad. Jobs, currently with Hadoop 20, it's worse because the jobs actually have to be resubmitted by the user, right? That's much worse. Why can't we just do a restart? Why can't we do availability? It's pretty hard because there's a lot of complex state in the job tracker, and reconstructing that state on 4,000 machines, it takes a lot of time and effort, and usually we don't have it. So that's one of the big reasons we haven't done the restart. We actually had an implementation of it, just did not work out very well. Right? One of the other big problems we've had with MapReduce is utilization. Because the MapReduce framework thinks of every machine as composed of map and reduce slots. Right? They're hard partitions, the map and reduce slots, which means the slots themselves are not fungible. We've had several cases in our cluster where all the map slots are full and the reduce slots are empty. Right? Which means half of the cluster is sitting idle. Or you have the other problem where all the reduced slots are full and maps are empty. So that's the kind of issues you've seen in the framework. Some more. This is actually a big one, right? Lack of support for alternate paradigms. How many of you have done MPI with MapReduce, Hadoop MapReduce? Just 2 hands? Man, I hate you guys. It's really, really hard to support it because the framework is just not geared for it, right? You can do MPI, you can do other frameworks on top of it. It takes a lot of effort for the users, I'm sure these guys will tell you. And it's really hard for the framework to support. That's a big problem for us. And it's not just MPI, right? Adaptive and adaptive algorithms are hard. So if you want to do k-means, it's hard. If you want to create ranking, it's slightly hard, right? The next one is lack of compatible protocols. Which means the client of the cluster has to be of the same version. So we can't upgrade different parts of the framework at different times. So if you have a job and you want to submit it to multiple clusters, it's hard if you want to upgrade. And that's worse for a case like Yahoo, where we have multiple clusters, and you want to run each one of them at slightly different versions. Right? You want to upgrade production clusters slower than the alpha cluster. So you won't be able to talk to multiple clusters. So some of the current limitations. Okay, so let's take a pause. As we go forward, what are we really looking for? When we start thinking about the kind of next generation of MapReduce, this is what sort of grow our requirements, right? So clearly we want availability and reliability. That's kind of motherhood and apple, right? Scalability, we really are looking to scale to 6,000 machines a year. Again, these are 6,000 machines of 2011 vintage, right? Which means with 6,000 machines, you can do more than 100,000 concurrent tasks and 10,000 concurrent jobs. That's a lot, right? It's something we just do not support right now. Biocompatibility is huge. We absolutely need to be able to talk to different clusters at different versions. And the last one is actually the most important one from our perspective, right? Agility and evolution. Now, one of the big problems we've had at Yahoo is that every time you bump up the version of MapReduce, you have to go through a cycle where all of our customers have to validate their new software, right? The framework has MapReduce isms kind of embedded at every layer. So every time you upgrade it, you have to go to a few hundred customers and tell them to validate the software against a new version. And that's really hard and really expensive, right? Now what we'd really like is for the end customer to be able to control which version of MapReduce they use. Which means you can upgrade the cluster, but as long as the end user can run his old version, it's fine, right? Or at least mostly fine. Now we've seen this with Pig, for example, or Hive. Now Pig and Hive are sort of client-side libraries, and you can run 3 different versions of Pig on a cluster as long as MapReduce works. As long as they're both on the same version of MapReduce. Right? Is this something you guys have seen? How many of you are running multiple versions of Pig or Hive? Right. So that was actually one of the big pain points from our customers, and that's what we wanted to support. Right? Okay, so what are we going to do about it? The big one is we want to split up the 2 major functions of the job track. The first one is resource management. The second one is application lifecycle management. Figure out which task of the application should be from how many resources are being consumed in the system. Right? Because fundamentally there are 2 different things that the job tracker is doing. Right? So once you do this, the application lifecycle management becomes a client-side library. So MapReduce becomes client-side library. Whether you want to run MapSlot, whether you want to run map tasks and reduce tasks, and what order you want to run them is effectively useful only at the client side. Right? It can be done on the client. It can be done as a client library. It doesn't have to be in your service. Right? So, what are we going to do? The idea is to basically split up into having a central resource manager and an application master, which does the lifecycle management. So, for example, in this case, we have a cluster. An application comes in. His client submits a job. You automatically, your first task becomes an application manager only for that job, right? And this guy can now start getting resources from the central resource manager and start launching his own tasks. Right? So, which containers, we call these containers at this point, which containers are given to this application master depends on the global state. And that can be done by the resource manager. But once you get the containers, what you do with them depends on the application master. Right? Does it make sense? The application master decides, all right, I need to run 10 map tasks at this point. So I'm going to get 10 containers where I can run map tasks. And then it decides, okay, I'm done with the map tasks, so I'm going to get another 5 containers to run my reduce tasks. So the great part here is that the framework, which is what we call the resource manager and the node manager, have nothing which is specific to MapReduce. Right? They're completely generic defaults. And all of the MapReduce specific scheduling and task monitoring and all of that is done by the app master. So if on these containers the map tasks are running, they talk only to the application master. and the application master realizes that, oh, they're making progress, they're slow, they're fast, they're done, they're killed, they're dead. Right? So all of that state management is done by the application master. Right. It's a generic slot at this point. And the container is defined in terms of generic resources such as CPU and RAM and memory. Right? And I/O and all of that. This bandwidth flows. So the responsibility of the application master to ask for the right containers. And what the resource manager will give you the right containers depending on your requirements. So, for example, if you want to do, how many of you guys have used the capacity scheduler or the fair scheduling? Right? So all of that capacity scheduling or the fair scheduling is inside the resource manager. Right? The resource manager has the global picture of all the applications running in the system. He knows the application requirements of all of them. Now, given that global information, he can do a global schedule and come up with the right resources for all of the applications in the system. And the policy you use depends on whether you want to do capacity stuff like the capacity scheduler or fair share like the fair scheduler. Does that make sense? Any questions on this? Okay, we can. Go ahead. Good question. The question is, how do you guarantee locality? The answer is, it's the responsibility of the application master to ask for the right containers. So once you ask for the right containers, the resource manager is going to do a match based on the availability of the containers. The application master can say, I want containers on these nodes or on these racks. The RM will say, all right, I can't give you a container on this specific node, but I can give you a container on a node in the same rack. And that's usually good enough, right? So that's how we do resource management. We have a very generic resource description language, or a resource description API that is going on between the app master and the resource manager.
What are the responsibilities?
Good question. What are the responsibilities of the node manager? The node manager at this point becomes a pure sort of container expert, right? The node manager, the only responsibility of the node manager is to get requests from the application masters and launch the containers, right? But the key there is that you want to have security burden, because otherwise your application masters are going to fake the responses, fake the requests. So the node manager actually has security built in, so you can verify that the container that you're launching was actually given to you by the resource manager. So other than that, that's all he does. He just launches the container, and when the container goes away, he will let the resource manager know. Saying, okay, right now I'm running these containers on me, and 3 of them completed, and these are the container ratings.
So then sort and shuffle today, and you get these intermediate files delivered by the task tracker. What do you do there?
So, as part of your resource description, you also ask for local storage. So the local storage is still managed by the node manager. We think of that as a resource. And we charge for that resource even after the job is done. So it's a cost model, right? So the node manager still does the shuffle. So it's not a per job shuffle. I'm going to talk about it. So we have availability.
So if the container fails, that has to reschedule.
So the question is, what happens if the container fails? If the container fails, it's the responsibility of the app master to ask for different containers. He will be told that his container is failed, or he can realize it himself. Depending on the fastest channel, you have multiple channels to realize it. But once you actually realize that the container is failed, it's the app master's responsibility to ask for more containers. So in some sense, one of the fundamental things that we've had with MapReduce today is that you can't actually launch, you can't add map tasks and reduce tasks after you launch the job, right? So that limitation now goes away, because there's not, that inherent limitation is not present in this new system. So the application master can decide if he needs more containers or less, depending on what's happening in this application. I mean, for example, speculation. How many of you are aware of speculation? Right? Speculation again becomes the responsibility of the app master to ask for extra containers. If he realizes that one of his tasks are slow, he can actually ask for more containers. Whether he gets them or not depends on the global scale or the global scenario of resources. Any other questions? Okay, I'll keep going. Okay. So I sort of covered this, right? So in summary, the resource manager is a global resource scheduler. We can do stuff like, we definitely plan to support hierarchical reviews. That's actually big for us. The node manager is the per machine agent. He manages the life cycle of just of the single container or the set of containers that we use, right? He also does container resource monitoring to ensure that the container does not exceed the resources that he's been allocated. And he also notifies the resource manager of the usage of the resources being used by every single container. Right? So you can actually make the resource manager can track usage of the resource on every node. We talked about the application master. It's per application, so for every single job or a tag of jobs, you can run one application master. So if the application master fails, you only lose that one application. Right? And we've got availability built in, so we can restart the application master. Right? He manages application scheduling and task execution. So it's his responsibility to make sure that his application, his job runs on completion. Right? Resource manager has no notion of completion of jobs. Right? The resource manager only understands resource requests and allocation of resources. Right? The obvious one that we're going to support is MapReduce application master. So all of the MapReduce specific stuff, the maps, the map site sort, all of that is going to be done. It's going to be something that only the MapReduce application master understands. The framework, the compute framework doesn't care about it. What you do in your containers is completely immaterial to the resource management. Right? Any questions? I'll take a pause. So the question is, what happens if the application master fails? So I'll talk about the availability of it. Okay, all right. So what are the improvements if you compare to current applications? Scalability, right? What we've seen over and over again is that management of the application lifecycle is very, very expensive. You guys have seen how we do roll-ups of progress reports, how we do roll-ups of MapReduce counters, all of that is now gone from the center. Right? So inherently, the RM is doing pretty much nothing which can be affected by the application themselves or the users. We partition resource management and application lifecycle management, and application lifecycle management is not really distributed. Right? The central guy is not doing application lifecycle. Like I talked about, in terms of hardware trends, this is huge because 6,000 machines that we buy this year or the next will be greater than 12,000 machines that we build in terms of their capabilities. So scaling is huge for us. And my ops guys always kill me on the fact that we can't support more than 4,000 users. Because at this point we're running tens of clusters. Some are 4,000, some are 1,000, some are a few hundred, some are a couple of thousand. So now we can actually consolidate all of them, and our operational costs are much better. It's huge for us. Availability. Everybody's favorite question, right? So, application master. What are we going to do if an application master dies? The answer is, it depends on the application master. Right? If the application master, which is not framework specific, whether it's MapReduce or MPI, he can implement a checkpoint himself. Right? For MapReduce, we are going to implement HDFS-based checkpoint. So we're going to save state on HDFS about the relative progress of every task. So if the app master dies, we can actually bring them back up from the state on HDFS. Right? the resource manager itself, we're going to do it by a zookeeper. Right? So the resource manager saves his state by a zookeeper, and we can actually quickly reconstruct all the state of the system by a zookeeper. And it's also the responsibility of the resource manager to start all of the application masters on bounces. So it's sort of distributed now. When the RM bounces, all he needs to do is start up all the application masters which were running when he went. So he's going to maintain that state. But once the AMs come up, it's their responsibility to reconstruct this. And it depends on the framework. If you're doing MPI, you can't reconstruct the state anyway. You might as well start your job from scratch. But if you're doing MapReduce, you can reconstruct the state. So it's completely application specific, and it depends on what the application master says. So the RM does not really care. But he is definitely responsible for starting the games.
So we're in charge of doing these checkpoints, right? Who's in charge of doing these checkpoints?
The application master. Yeah.
So if we don't get the checkpoints right, the state shifts it up. And when we take over, we will lose everything.
Right. And for example, so some frameworks it doesn't make sense to checkpoint. Right. So it depends on the application. It depends on what you're doing in the application master. But the Hadoop framework will definitely support checkpoints for MapReduce. Right. The MapReduce application masters that we write will support checkpoints.
So is the checkpoint like as a MapReduce developer, do I have to?
No. So as an app, sorry, that's a good question. Does the MapReduce developer have to do anything? The answer is no. Because the MapReduce application master is still done by Hadoop itself. There is one application master that you don't know about. You just run the Hadoop job. But if you're writing your own framework, you got to. If, for example, at some point in the future we support an MPI application master, we will, or some other application master, we will. But if you're writing an application master that we don't know about, we can't support.
So what gets you to the checkpoint on the job?
We actually did the checkpointing with job trackers. What happened was reconstructing that state on failover was very expensive. And because you had to reconstruct it in one place for thousands of jobs, it took us forever. Because there's only one guy who could actually reconstruct this. Here, the nice part is it's distributed among all the applications. That's a great question, right? So the question was, why didn't we do it in job tracking? We actually tried that. It was really, really hard. We tried it, we fixed bugs, eventually we did it. In fact, I think in 21 we have a version where we just restart the job. We restart the job on a bonus. But we don't start exactly where it left. That was expensive.
Why is this any more or different than what Mesos already does?
What more or different?
Doesn't Mesos already do all this?
So what? I can answer that question. Do you want to come back again? I'll run through the stuff. Any questions on availability? Oh, wire compatibility. The answer is simple. We're going to use wire compatibility. We're going to use a serialization system to do this. So old clients can talk to new servers and vice versa, and we can do roller backwards.
Wire compatibility, you mean there's no network interface and
Use of things, something like protocol buffers or Avro. So you can actually deal with changes in your fields on the RPC messages.
someone's having to deal with both changes,
Right.
however many there are.
Right. So you use either Avro or protocol buffer together. The RPC servers and the clients. Just because you do it in serialization. You send an object out. If the fields have changed, Avro or protocol buffers can handle, can either drop the old fields or provide defaults.
If the protocol should set up that,
Oh yeah.
it's not possible.
No, I mean again, you need discipline. It has to have the same interface. It has to be a compatible interface. It's kind of like what API tools have. All right, so this is actually, like I talked about, this is big first, right? MapReduce now becomes useful like there's no daemon or there's no framework of MapReduce. It's all in the application master. So now you can actually run multiple versions of MapReduce at once, right? You can run a 20 version of the MapReduce AM and a 22 version of the MapReduce AM. And as far as the framework is concerned, it doesn't matter. So we can actually support multiple versions. Exactly similar to what you do with Pig or Hive for everything. Right? Customers can now choose to upgrade on their ship. You don't have to have a 2-month cycle where every single customer in your company needs to go through an upgrade cycle. The next one is also important, which is you can do something other than MapReduce, or you can take MapReduce and tweak it for your own needs. I mean, I don't know how many of you guys have looked at Paul, online coding. You can do all of that, right? Because there's nothing in the system which cares about this. The framework doesn't care. And the nice part is, if you customize your version of MapReduce, you don't affect every single user who uses it. So today, if you had to add a new version of an optimization to MapReduce, we can do it for one AM and give it to one customer and keep it tested without affecting every other customer on the same. That's actually huge. Right? Utilization. Like I said, we have a generic resource model, memory, CPU, disk, and network. And they fixed the partition. We no longer have partitioning between map and reduce nodes. So every slot is fungible. And you can also ask for bigger slots or smaller slots. Think of this as the EC2 ground. Right? You can ask for fat ones or small ones. And depending on your capacity or your fair share or whatever it is, you'll get them at the appropriate time, depending on the rest of the system. Right? Support for other paradigms, MPI, master motor, machine learning. We have a huge number of researchers at our door at this point trying to write MPI and master motor and other stuff. That's going to be really exciting. The really nice part, of course, is that you can run all of this on the same room. You don't have to have different frameworks to be able to run MPI. Right? And a lot of people do it with writing on top of MapReduce, but you sort of have native support in this. Okay, summary. Scale out even further. That's huge for us. High availability, utilization, and support for paradigms. So how does it support machine learning and so on? You can write an application master which is specific to exactly